Here we're going to introduce what's called the common log function, the natural log function, and we're also going to talk about the domain of log functions. So first of all, if somebody gave you the function f of x is equal to 2 to the x, we know that we can find the corresponding log function for this exponential function. And when I say corresponding log function, what I mean is the log function with the same base, a base of 2. So if f of x is 2 of x, the inverse, which I'll denote right now as g of x, is log base 2 of x. Now, to make explicit that we're talking about the inverse, people often, instead of writing g of x, they write this. F inverse of x is log base 2 of x. Okay. Now, it turns out that there are certain bases that occur in lots of different situations. And the first is the base of 10. And that makes sense because we're in a base 10 number system. So if somebody gave you the function f of x was equal to 10 to the x, well, that has a corresponding inverse log function. And that inverse function would be log base 10 of x. Now, it turns out that this occurs so commonly that nobody writes the base of 10. So on a calculator, or if you just see in a textbook, for example, or here in this video, if I just write f inverse, or if you just see this function log of x, that simply means log base 10 of x. This log function is called the common log function because it occurs so commonly because we're in a base 10 number system. So just log of x, the assumed base is 10. And likewise, if you have the function f of x is e to the x, right? This is the natural exponentiation function with the base of e. Remember, e is about 2.71828. The inverse of that function would be log base e of x. Now, nobody writes this. Instead, we write this. F inverse is ln of x. Okay, so this is ln of x, and it's called the natural log function. Natural log. So we just write ln instead of log base e. You don't write ln with the base e. The base e is implied by the letters ln. And the reason we call it the natural log function is because a lot of natural phenomenon involve, through the use of differential equations, the function with base e, and therefore the corresponding, or the exponential function with base e, and therefore the inverse of that function, which is the natural log function. Okay, so these are two log functions that arise often, the common log and the natural log function. Now, what about the domain of log functions? How do you address that, or how do you find the domain of log functions? Now remember, the domain of just log base of log of x, the domain is 0 to infinity. In other words, remember that for the domain of a log function, the argument has to always be greater than 0. So if we're asked to find the domain of this function, log of 1 minus x squared, and note that this is common log because the unwritten base of 10, this is base 10, just the 10's not written. What you do is you always, when you're looking for the base of a log, or the domain of a log function, is you set the argument greater than 0. So in this case, we require 1 minus x squared to be strictly greater than 0. And the way you solve this quadratic inequality is by factoring the left-hand side once you have the right-hand side to be 0. So if you factor this, you get 1 plus x times 1 minus x, and you want that product to be greater than 0. And then what we do is we look for numbers that cause each of these to be 0. So this first factor is 0 when x is negative 1, and the second factor is 0 when x is 1. And then you put those on a number line. So this is our strategy for solving quadratic inequalities. We have a video on that as well. So you put a negative 1 and a 1, and then you pick test points. So if you plug in negative 2, for example, this factor would be negative, this factor would be positive, and the product would be negative. Between negative 1 and 1, if you plug in 0, this is positive, so the product would be positive. And beyond 1, if you plug in like 2, this factor would be positive, this factor would be negative, the product would be negative. And then you go back to your inequality and it says, hey, when is that product strictly greater than 0? Well, that occurs here with a positive sign between -1 and 1. So the domain for this function would be -1 to 1. Okay. Now notice that we can't plug in the actual numbers -1 and 1 because those are places where the argument would be 0 and the log function is undefined at 0. Okay, so or the log function is undefined when the argument is 0, I should say. All right, for the next example, let's find the domain of f of x equals the square root of x plus 1, take away natural log of 5 minus x. Now notice that we need both expressions to be defined. So because this is the square root function, we need x plus 1 to be greater than or equal to 0. So our first condition, x plus 1 is greater than or equal to 0, and that implies that x is greater than or equal to -1. And the second condition implies that 5 minus x is strictly positive because it's the domain of a log function, in this case the natural log. So here we need 5 minus x to be strictly greater than 0, and that implies that 5 is greater than x, which means that x is less than 5. Okay, so we need both of those conditions. We need both x to be greater than or equal to -1 and x to be less than 5. And if you put those together, what you get is the domain is going to be -1 to 5. And so let's write that down. This is our domain. Okay, so it's the intersection of these two sets. We need both of them to be satisfied. Okay, so that's how you find the domain of log functions. Until next time.